Airplane wings first made of wood are now almost exclusively made of aluminum alloys. Bauxite is the mineral aluminum is refined from. The Baer process begins with unrefined bauxite that is crushed and milled and put into a pressure vessel at temperatures ranging from 150 to 200 degrees Celsius along with sodium hydroxide. The aluminum dissolves and is filtered and then crystallized. It is then heated again in solution in the Hall-Héroult process. It breaks aluminum oxide and carbon into pure aluminum and carbon monoxide. The pure molten aluminum taken from the electrolytic process is then drained from the bottom and poured into ingots. These ingots are then processed into thinner sheets for manufacturing.
The manufacturing of aircraft wings can be broken down into three categories: the ribs, the spars, and the wing skin. Firstly, starting with the ribs, a computer-guided punching process punches holes in aluminum sheets to be able to be joined to the spars of the aircraft. The computer will also punch larger holes out of the center of each rib to help contribute to the weight reduction. After the punching process is completed, the rib patterns will be disconnected from the aluminum sheets via micro joints, which will be broken so the ribs can be extracted. Once ribs are disconnected, they will be placed in a forming die process. A press will stamp the ribs into the desired die shape. This usually bends all ends upward to allow for final assembly. Moving on to the spars will also use a punching process similar to the ribs to obtain their desired shape and connection points. This will take longer sheets of aluminum as the spar runs the length of the wing. However, once the spars have been punched, they require sheet metal bending to obtain their final shape and will require a greater force to shape due to its thickness being at least 3 times that of the ribs. And finally, the wing skin, also starting from aerospace-grade aluminum, is first polished to aid in the protecting of the surface from reacting with oxygen. Then, after it has had time to set, the aluminum sheet is put through a milling process to cut out very specific geometries and patterns. This will help shape the wing and make room for the internal components. At this point, the recently milled wings are very ductile, which allows them to be formed into the desired shape with a complex system of suction cups that allows for easy shaping of the wing into the desired shape. The preformed wing is then heat treated to set its shape and harden the material.
The actual assembly of the aircraft wing is an important part of its manufacturing process. As the aircraft wing is assembled from materials previously discussed by our group, there are a few different processes that are used. The first of these processes is the drilling of holes done on the aluminum skin of the wing. As discussed in class, drilling is one of the conventional machining methods used in which several round holes are created by a machine spinning a drill bit into the surface of the metal. Another one of the processes used is riveting, which is a permanent metal fastener that is added to the wing structure, typically by hand, by deforming a smooth cylindrical shaft in order to create tension on each end of where it is fastened. The last notable manufacturing process used to assemble the wing is the use of metal fusion. An argon torch is typically used to weld using a filler rod, and this process is only used on the fuel assembly portion of the wing. Bolting of the fuel assembly is then done by hand to ensure a smooth structure.